Consider this before viewing Destination Mars, Part 1. What do you know about NASA's plans to visit Mars? How long will the trip take? What supplies and equipment will the astronauts need to survive there? As you watch the program, take note of the goals of the first manned mission to Mars. What do you think are the risks of traveling to such a distant planet? What would you want to bring with you? Assignment Discovery now presents Destination Mars, Part 1.
Mars, the red planet. Rockets have reached its bone-dry surface, but not people. The space between Earth and Mars is a hostile place to travel. Even specks of meteor dust could smash a spaceship apart. Getting there will require untested human courage and the best minds in science. But sometime early in the next century, we could send astronauts to our neighboring planet.
Mission Control, Explorer 1 has landed.
The journey is 250 million miles. It would last 2.5 years, including 18 months on the Martian surface. The greatest adventure since mankind landed on the moon. This time, the destination is Mars. Only a third the size of Earth, its volcanoes are as wide as the state of Missouri, and its tallest mountain soars 3 times higher than Everest. Some river valleys are as wide as the Grand Canyon is long. Gravity here is less than half of what it is on Earth. Days are only a few minutes longer, but a year is twice as long. And it's so cold that all its water is locked up in the polar ice caps or frozen beneath the surface.
We have a go for engine start. 6.
For most of us, a mission to Mars might seem like science fiction. But in fact, we're almost ready to take off. Since the days of Apollo, a dedicated few have kept the dream alive by developing ingenious ways of surviving in space. New technologies would reduce the cost of the mission by 90% and cut travel time in half. And the countdown has started. Sometime early in the 21st century, the first manned mission to Mars could be ready. Their goal, to look for proof of life on Mars. They'll also search for valuable minerals and test the feasibility of human settlement. The trip would be timed to start as the Earth was about to swing past the red planet, which occurs once every 26 months. With a tug from Martian gravity, they would use less fuel and get there in just 6 months. One design on the drawing boards is for a Mars spacecraft at 27 feet in diameter, divided into 2 decks. The upper deck contains the crew's quarters, which would also double as their habitat on Mars. Worldwide interest in Mars has never been greater since NASA held a press conference to announce the discovery of this small meteor. Knocked off the surface of Mars many millions of years ago, it crashed into the Earth by chance. Inside, scientists found minerals that could only have formed in water. Along with the minerals were other structures that could have been produced by bacteria-like creatures.
The simplest explanation to us is that they are the remains of Martian life.
The meteor and another discovered by British scientists were tantalizing clues we might not be alone in the universe. But not everyone agreed with the evidence. Is there really life on Mars? It's an age-old question that's puzzled scientists for centuries and triggered an ongoing debate about manned or unmanned missions.
There's a thought that maybe we ought to send people to try and understand the history of life on Mars. The issue is we send robots to do a broad reconnaissance of the planet to isolate those places where humans might go. And after we send robots on the surface, we want to bring back samples with robots to get even more evidence. And then, if the evidence is overwhelming, then we go and we send people.
American spacecraft rendezvoused with Mars 6 times between 1964 and 1976, Viking 1 and 2 actually landing on the surface. The payoff was spectacular. They sent back images of a planet that looked remarkably like our own. To see if there was life on Mars, each Viking lander scooped up a sample of soil. Of 4 chemical tests run on each sample, 3 were positive. But the results of the 4th and most important test were negative, leaving the question still unanswered. Photos taken from orbit showing strange parallel lines and a rock with the impression of a face rekindled speculation about a lost civilization. But it was images like this, what looks like frost on a summer morning, that intrigued scientists most. Ancient river channels signaled that Mars used to be warmer and had flowing water. And polar ice caps gave proof that water was still there.
They showed us the real Mars. They showed us a planet that was not like we had imagined, not with canals and civilizations. But they showed us things that were just as interesting. They showed us that at one time Mars was a different world, a wet world, an active world, maybe a lifelike world. And that image, the notion that there was at one time 2 Earth-like planets in our solar system, has been the driving focus for Mars research ever since.
Mars Explorer 1, your go for TMI.
After checking all systems on their spacecraft, the crew would take its last look at planet Earth as it prepared to leave the relative safety of Earth orbit.
Roger, go for trans-Mars injection. 30 seconds till burn.
In 10 minutes, they would burn all the fuel in their upper stage rocket and begin the long coasting ride to the Red Planet. This would be the last time Mission Control could directly oversee a critical maneuver.
10 seconds till burn.
Soon the spacecraft would be out of the range of communication.
Engines armed.
5, 4, 3, 2, 1.
The end of the burn would signal the first momentous step for a 6-month journey to Mars.
Success to Mars.
Hey!
With the upper stage rocket and its fuel gone, the crew would have reached the point of no return. The same upper stage rocket that took Apollo to the moon could be used for the journey from Earth's orbit to Mars. Returning from Mars is where Zubrin's machine comes in. He would split every Mars mission into 2 launches in a plan called Mars Direct.
In your first launch, you fire off to Mars an unmanned payload consisting of an Earth return vehicle. Okay, this is a little rocket ship that's going to be used to fly back from Mars to Earth with a crew of 4 astronauts in it, but no one's in it right now. It flies out to Mars unfueled. Its fuel tanks are empty. And once it's landed on Mars, it makes the fuel and oxygen it needs to come home. It takes perhaps 5 to 10 months to make the fuel. Of course, the people on Earth have monitored this So long before the next launch window opens up, we'll know we have a fully fueled Earth return vehicle waiting for us on Mars.
The crew would land their spacecraft within a few miles of the return vehicle. When the time came to leave, it would be abandoned. Because Mars Direct is economical, NASA mission planners like John Connolly embraced the idea with only a few changes. The major change was to put a large return spacecraft in Mars orbit so that when the crew blasted off from Mars, they could transfer to something with a little more legroom. But the basic idea of living off the land had taken hold.
When we're going to Mars, we're going to start thinking again like the pioneers did. We're going to start using the land for our subsistence as much as we can. If you think about the early pioneers that pioneered the American West, they didn't load up their Conestoga wagons with their logs to build their log cabins. They went to wherever they were going in the Midwest and they started cutting down trees there. They lived off the land. They started growing their food there. They didn't bring it all with them. If they tried to bring everything they needed with them, they would have never made it past the Appalachians. We're going to Mars in the same way.
Scientists are developing the technology to recycle air and water for a Mars mission, including a machine that can turn urine into drinkable water. In another experiment, a NASA scientist is taking a much less natural approach to using plants for a complete life support system.
Hi, Greg. Almost ready for harvest this afternoon?
Almost ready.
Here in a chamber just 200 feet square, David Bubenheim has plants growing 10 to 20 times more densely than they do in nature. Rather than imitate real ecosystems, he's manipulating the plants in every artificial way possible to achieve a healthy and steady harvest.
People are going to depend on this for their life. So we're trying to be able to show that we can maintain for an extended period of time all the food, all the air, all the water that a crew needs while recycling their waste.
Based on experience with the prototype, they know exactly how big a system would be needed to support a real base on Mars.
This chamber is about 200 square feet, and for a crew of 4 people, it would be able to supply and recycle all the air and water. But it wouldn't supply 100% of the food in that case. To do that, you would need an area about 4 times this large, or a chamber about this size per person.
Bubenheim is now experimenting with the color of light to try to reduce the energy needed to run the system.
Well, in all the scenarios we're considering for a space-based habitat, energy is extremely limited. And if we're going to take electricity and make light, we need to use it very efficiently. If you look at these wheat plants that are growing under white light, like plants would outside, where all colors of the spectrum are represented, you can see that there are a number of smaller side shoots that are grown.
Those side shoots are waste that has to be recycled because it's only the taller center shoots that produce grain. But growing the wheat under blue light eliminates the side shoots, leaving the important center ones unharmed. Red light works the same. If the color of light can reduce the waste for crops other than wheat, plant-based life support will become even more attractive. But can a plant-based system work reliably over an entire Mars mission? At least one astronaut fears there could be a crisis. Story Musgrave.
If there is any form of virus, bacteria, disease, or the plants for some reason become not healthy, then that balance is thrown off and it's fatal.
The kinds of designs that we're looking at in actually building one of these for space would actually provide us some segregation. So if the disease were to come into one section, it could easily be separated and quarantined so that the disease didn't spread to the rest of the plants. Roger, Mars Explorer 1.
But as the Russian space station Mir revealed, the greatest risk to the crew on the long voyage to Mars may be weightlessness. Our bones and muscles are only as strong as they need to be. In space, with no gravity to tug on the human body, bones lose calcium and muscles lose strength.
The
In 1995, the United States began sending astronauts to the Mir to see how the Russians managed to stay in space for a year or more. Astronaut Shannon Lucid broke the American record, 6 months. Astronaut Norman Thagard spent 4 months on Mir, with the Russians a likely partner on the mission to Mars. Thagard collected detailed information on his body's reaction to zero gravity, but mostly he tested Russian techniques for counteracting the effects of weightlessness.
The Russians have a lot of experience in long-duration spaceflight, and they realize that if you don't exercise diligently when you're on these long-duration missions, then you won't be in good shape when you return. Toward that end, the Russians schedule 2 one-hour exercise sessions a day.
The goal of these exercises is to subject bones and muscles to the same forces and stresses they would get on Earth, so that they can remain tuned for Earth's gravity.
Knowing as I did, because I am a medical doctor, that I would quickly get out of shape if I didn't exercise, I was extremely diligent in exercise for the whole while I was on the Mir station.
When Thagard returned, everyone was eager to see if his exercising had paid off.
When we landed, within 10 minutes of wheel stop, I stood up. Wasn't the easiest thing I ever did, but I did stand up, and I remained standing until they opened the doors and got everybody out ahead of me, and then I walked off the vehicle unassisted.
Even if cosmonauts follow their exercise routine, some can't cope with gravity after 6 months or more in space.
The issue of what sort of shape folks need to be in when they get to Mars is probably a bigger one than it is for low Earth orbit, in the sense that in low Earth orbit, all you have to do is come back, and if need be, they can carry you off the vehicle. But when a crew is going to Mars and they arrive, they need to be in good enough shape to do real work.
Rotating a spaceship to produce artificial gravity has long been considered the ideal solution to the exercise problem. The principle behind artificial gravity is a familiar experience. When a roller coaster goes around a loop, it creates centrifugal force, which presses it into the track. A rotating spaceship would also produce centrifugal force, pinning astronauts to the spaceship floor, simulating gravity. The most promising technology for counteracting the harmful effects of weightlessness was recently tested by NASA in a bed rest study. First, volunteers laid in bed with their heads tilted down, a position that caused the same problems astronauts get from zero gravity.
You do, have a little lower back pain, get a headache usually. I think maybe my head's a little fuzzy sometimes too from being in this position, so kind of difficult.
Fluids move up to my head, I start to get puffy and my nose starts getting congested.
Your muscles start to atrophy, and that continues, and then eventually you'll start losing bone.
These tests are obviously no picnic for the people who do them.
What's the surprise?
It tastes good at first, but getting it down past your throat gets more difficult.
The object of all the inconvenience was to test a new, improved treadmill for use in space. The problem with current treadmills is that they rely on elastic straps to produce force, and elastics pull harder the farther you stretch them. If the elastic is strong enough for an astronaut to feel his normal weight when he gets on the treadmill, then the elastic will be too tight for him to lift his body up and run. So to be usable, space treadmills can only have weak elastics that produce moderate force, which limits their ability to maintain bones and muscles. The new machine uses a vacuum pump to pull the runner into the treadmill, allowing much higher forces. To simulate a workout in space, Brent Walker had to run lying down, so the Earth's gravity wouldn't be a factor.
Brent, we're putting up the treadmill now.
Pick yourself up.
Okay, vacuum's on. Okay, I'll bring it up to full body weight.
As the vacuum sucked air out of the chamber, Brent's feet were pulled into the treadmill. Lying sideways, yet feeling like he was standing upright and bearing his normal weight, was an odd sensation.
You do get used to it, and sometimes it feels like you're almost flying effortlessly. It's a very strange feeling. You do sweat, though.
Because the machine is experimental, Brent was asked to rate his stress.
Exertion? It's a 13. 13? Okay. Heart rate's 170.
Feeling your normal weight while exercising in space would be double what astronauts get from elastic straps, but the treadmill can also make you feel much heavier.
Okay, Brent, I'm bringing the pressure up to 1.2 body weight.
The harder the vacuum pulls, the more stress on Brent's bones and muscles.
Well, it feels like I have a backpack on, about 30 pounds, something like that. It's just a lot heavier. Definitely just stress in my lungs and my muscles a lot more. It's hard.
The question is, will 40 minutes a day on this vacuum treadmill prevent bone and muscle loss during this study?
I feel my muscles are a lot stronger. They've actually, since I came into it, they've gotten a lot stronger. So I would imagine that it will help me. I mean, it's really difficult from my point of view, to know until I actually stand up.
After 2 weeks in the bed rest study, the moment of truth arrived.
Your mark, get set, go!
Brent actually ran faster than before he got into bed.
On your mark, get set, go!
But those who didn't use the treadmill during the study, like Bill Davis, were much slower than before.
I think it's just a feeling of sort of weakness, of not having a lot of energy or a lot of strength.
This is Mars Explorer 1, 10-4.
It would take about 102 days for a Mars mission to reach the halfway point on a journey to the Red Planet. Each morning would begin with a routine 1-hour exercise session, including the vacuum treadmill. Astronauts would know the importance of being in good shape when they get to Mars, where they would have to deal with gravity again. The crew would use regular exercise to relieve their boredom during this part of the mission.
I'll be up front.
All right, I'll come and get you if I need you.
But there could also be times when no one would think about exercise. On board, alarms might warn that invisible but deadly ions from a solar flare have penetrated the spacecraft. Every second of exposure can increase damage to the body, so the crew would quickly retreat to the only shielded area. Barely 5 feet square, the emergency shelter would maintain a supply of food and allow control over the most vital systems on the spacecraft. The solar flares could last for a few hours, or a week, or even longer. Travel in deep space is inherently dangerous and unpredictable.
Now that you've seen Destination Mars Part 1, talk about this. The goal for NASA's Mars Direct program is to send survival resources to Mars several months before humans arrive. What materials do you think the first spacecraft should bring to make the astronaut trip successful? Discuss how scientists are planning to recycle food and water during such a mission. Now try this. Design a remote vehicle for traveling around on the rocky surface of Mars. Be sure to describe its fuel source, weight, size and shape, the way it moves, and any special tools such as cameras and analyzing devices. Present your work to the class. Log on to DiscoverySchool.com for curriculum materials and resources to support Destination Mars. To learn more, Assignment Discovery suggests Uncovering the Secrets of the Red Planet Mars by Jack Hamilton. Consider this before viewing Destination Mars Part 2. What do you know about astronaut training? How would you create a training environment on Earth that simulates the reduced gravity and weight the astronauts will actually experience on Mars? While watching the program, take note of how spacesuits are designed and tested. What special materials are used, and what purposes does the suit serve? Assignment Discovery now presents Destination Mars, Part 2.
Russia's space station Mir holds the record for flights of long duration. Today, cosmonauts spend up to 14 months in space, twice as long as the trip to Mars and almost half the length of the entire mission. Long stays can be enhanced by some of the comforts of home. Mir has even had a steam bath, where cosmonauts could take a traditional Russian banya complete with a birch branch. But the cosmonauts have learned that over time, things can go wrong, as they did for Vladimir Titov and Musa Maranov during their 13-month mission.
2 months into our flight, we had an orientation problem. The space station drifted out of alignment with the sun, and suddenly we couldn't charge our solar batteries, and so we lost energy. And that was scary because we had to turn off all the lights. The fans stopped. Electricity was low on the ship. We were trying to get out of this situation for a long time, about 3 weeks. We had to restore all the devices that didn't work.
While they could have taken a lifeboat capsule back to Earth, something that wouldn't be possible on a Mars mission, eventually they resolved the crisis. But then a new one arose.
There were moments when we got bored with each other. Mostly, it was the result of psychological stress. We never really fought. Instead, we just went to the porthole and observed the Earth. Did our own thing when we got bored. Fortunately, whenever we had important jobs to do together, all the problems between us would vanish.
How will we select a crew for the first human mission to Mars? People who can handle both the risks and the stress. The answer may lie behind these gates at Russia's Cosmonaut Training Center, Star City. In the United States, psychological factors play a small role in deciding who goes into space. But in Russia, psychology is central. At all the milestones of a cosmonaut's training, someone like psychiatrist Oleg Rumin is there observing. Today, Oleg Kotov is taking his first ride in the centrifuge to see if he can withstand the G-forces of a rocket launch. To test his ability to concentrate under pressure, he's told to press a button every time these lights go on. Oleg will be subjected to nearly 7 Gs. In the control room is the psychiatrist Oleg Rumin.
I'm looking on his expression and behavior reaction, and I'm looking for his eyes. It's viewing just one point or maybe space around him.
The test lasts only 5 minutes. From a physical point of view, Oleg did fine. And from the psychological?
A little bit nervous, but this is the first rotation on a centrifuge for this young cosmonaut. And this is a good person. I like that.
Aboard Mir, many of the things that crews treasure most on long-duration missions won't be available on a trip to Mars. Distance will prohibit the real-time back-and-forth video conferences with home that cosmonauts enjoy at least once or twice a week. Portholes, which allow the crew to look back on Earth whenever they're homesick, will be useless.
A flight to Mars will be a frozen picture of unmoving stars, and the Earth will be just a dot among them.
Mission Control, this is Mars Explorer 1. Hope you're reading us.
Even after 192 days in space, the crew would still be able to communicate with their families.
Your mom had her checkup yesterday and her blood pressure's fine, so stop worrying.
But the time delay would be frustrating. The astronauts would have been drifting in the darkness of space for almost half a year.
How proud you are. Okay, I'm going to pause now, because I know you won't get this for another 20 minutes, and then I have to wait to hear back from you. So I think I'll go work in the garden for a while.
By this time, they would be close enough to Mars to make out some details. 10 more days, and they would be able to set foot on the red planet. After about 202 days, the Mars spacecraft would reach its destination and gravity would draw it into orbit. The captain would begin a last-minute virtual reality session to rehearse for the landing. He would have been practicing throughout the mission to be sure the descent to Mars would go smoothly. The Martian surface must be monitored closely for violent dust storms that can appear with little notice. Such a storm destroyed an unmanned Russian spacecraft that landed on Mars in the 1970s. From Mars orbit, the crew could also see the specific places they've come here to explore. Places where previous robotic missions detected minerals that might lead to evidence of Martian life, and to crucial underground supplies of water.
Mars has water. There's oceans of water frozen into the Martian soil as permafrost, enough that if the planet was flattened out and the water was melted out of the soil, the planet would be under 600 feet of water. Now that's dry compared to the Earth. If the Earth was flat, we'd be under 6,000 feet of water. But the Earth's a water world. If you got rid of the Earth's oceans and froze the rest of the water into the soil, the Earth would be about as wet as Mars.
With just 36 hours to go until the touchdown on Mars, a crew would exercise harder than ever. After 6 months of weightlessness, they would soon have to cope with gravity again, and moving around on the surface in a spacesuit would not be easy.
Man, it didn't feel like this stuff was that hard.
One of the most crucial technologies still lacking today for a Mars mission is a practical spacesuit. Apollo moon suits were little more than inflexible pressurized bags, adequate for life support but awkward for getting around. The Mark III spacesuit, designed and built at Johnson Space Center in Houston, is a major improvement. It was intended for zero-gravity work on the space station, so it's probably too heavy for Mars. But it demonstrates how putting dozens of airtight joints around the suit lets a person bend and move in a natural manner, while still getting the protection of a pressurized shell. The first steps for designing a Mars suit have already been taken in this water tank at the NASA Ames Research Center. Because people naturally float in water, to simulate Martian gravity, research subjects wear a series of weights distributed all around their bodies.
Okay, are you ready to exit onto Mars?
Martian gravity is 39% of the gravity we have on Earth, so a 150-pound man would weigh only about 60 pounds on Mars. He would also fall more slowly when he jumped up and down, but not this slowly.
Why don't you add about 4 in the front, and then add about 2 in the back, and then...
Bruce Webben is director of the spacesuit program here, and he's realized that his subject Eric needs a few more weights. Eric should now feel as heavy as if he were on Mars.
Okay, power's on. Motor's on.
Part of what Bruce Webben wants to know is how far a person's joints bend when he walks in Martian gravity. This will determine how flexible a Mars spacesuit must be to allow natural movement.
We're at 1 mile an hour now. We're going to go up to 3 miles an hour, okay? Okay, 3.
Webben also wants to know how much less energy it would take to walk in the lower gravity of Mars compared to on Earth.
As you decrease the gravity, it makes sense that the effort to move would probably be less. But if you go all the way to 0 gravity, then you can't walk. It's a completely different means of locomotion. And so the real interesting questions are what happens in between, and so we need to learn what sort of effort it takes to move and walk on Mars.
While the research subject exercises, Webben measures the carbon dioxide he produces, one way of gauging the expenditure of energy. This will determine how big an air tank astronauts will need to do a day's work on Mars, and how much air conditioning they'll need to stay cool.
If this kind of research isn't done, then what would typically happen is, as an engineer, you would over-design. So you would always design the system to be safe, but it would be much larger. The life support system would be much larger than it really needs to be, and the suit would not be optimized at all.
To perfect the design of a Mars spacesuit, Webben hangs weights at various places on a backpack frame. This will help determine the best place to concentrate the mass of the life support system, as well as where astronauts should carry things like tools or geological samples collected in the field. Each time the weights are moved, Webben measures how that affects the subject's balance, comfort, and energy consumption.
Eventually, we'll learn how to distribute the mass of the life support system. It won't necessarily be a backpack. It might be that it's more efficient to have the life support components distributed around the body, some of them in front, some of them in back.
Webben says he could build an ideal Mars suit in just 3 or 4 more years, but further work has now been put on hold by NASA. The crew must land their spacecraft near their return ship that arrived on Mars 2 years ago. By this time, it would have made the fuel needed to get
10
home.
seconds of deorbit burn. Enable engines. Engine enable. Burn beginning.
Thrusters would reorient the craft to begin the descent to Mars.
Making contact with Mars atmosphere.
G level. 0.75 Gs. Velocity. 2,000 meters per second. 1,700 meters per second.
1.9 Gs.
1,300
Their
meters
speed
per
would
second.
drop rapidly, and the G levels would climb as the spacecraft's huge aerobrake would produce friction with the Martian atmosphere.
600 meters per second.
Picking up signal from return vehicle.
1.9
And locked onto target.
Ready to deploy main parachute. 5, 4, 3, 2, 1. Begin terminal descent burn. 200 feet.
80 feet. 40 feet. 25 feet. 10 feet. We're down.
Mission Control, Explorer 1 has landed.
We have long dreamed about setting foot on Mars.
This is the proudest day of my life.
Television pictures would arrive back on Earth 20 minutes later.
It feels really strange walking, doesn't it?
The landscape has a similarity to the scenery back home. And the water-eroded hills suggest that Mars has a captivating story to tell. Almost 4 billion years ago, Mars and Earth were nearly twins. Both were warm and wet. But for reasons unknown, Mars rapidly became cold and dry. The Explorer 1 crew would land in one of the great river valleys where water was abundant during Mars' warmer days. A manned mission would hope to learn whether life got a foothold on Mars before conditions became so extreme, and whether life still exists beneath the surface today. But the crew's first priority would be to confirm that the return spacecraft that fueled itself from the Martian atmosphere was still in good shape for their journey home. They would also set up a series of weather stations to avoid being caught off guard by a Martian windstorm, which can gust up to 80 miles an hour. Only then would astronauts drill into the frozen floor of an ancient riverbed, searching for minerals, water, and evidence of life.
The possibility of finding some ancient form of fossilized life or some anaerobic life, that is, life that doesn't depend on oxygen living under the land on Mars, would be stunning. Because on this planet, we've all looked up at the sky and wondered, are we alone? Are we unique? Is life unique of any form, however complex or lowly, carbon-based or not? Is life unique to planet Earth?
A crew would be on Mars for a year and a half conducting field work.
We can be there in 2 hours.
For safety's sake, they travel in pairs. They would explore the bottom of ancient lakes where canyon walls slice through millions of years of Martian history, and with luck, they'll reveal some evidence of past life. Within a rock like this, could there be unmistakable evidence that columns of bacteria-like creatures once lived on Mars? If so, our understanding of the universe will never be the same. With each new day, there would be new discoveries to make, new possibilities to explore. Mars experts believe the crew could locate underground ice that could be melted for water. This investigation might change the future of Mars, a dream held both by science fiction writers and by scientists. NASA's Chris McKay believes that we could make the red planet's climate suitable for life through a process called terraforming.
The word means, obviously, to make it like Earth, terraforming. Fundamentally, what Mars lacks is a greenhouse effect. Like the panes of glass in this greenhouse, the carbon dioxide and water in an atmosphere hold the solar energy in and keep a planet warm. Mars' thin atmosphere is essentially equivalent to no greenhouse at all. The first thing we need to do is give it a thicker atmosphere or somehow augment its greenhouse effect. That greenhouse effect would allow temperatures to rise, water to flow, and then life could be introduced on Mars, and then life could survive.
The Mars of today is hostile to life, lacking any liquid water on the surface, and colder even in the summer than the coldest it ever gets on Earth. But during the first human mission to Mars, the crew would conduct an important terraforming experiment to test whether the Martian climate can be changed. By constructing a greenhouse that traps heat from the sun, they would find out whether raising the temperature forces carbon dioxide, a greenhouse gas, to come out of the soil, as Chris McKay predicts. After a few days, they would return to the greenhouse to measure how much carbon dioxide has accumulated. If the increase is large, it would suggest that terraforming Mars, making it Earth-like, could really happen. Once humans have set foot on the red planet, dreams can start to become reality. But which dreams will we fulfill? Will we construct settlements here? Will Mars become an extension of the world we live in today?
I think 200, 300, 400 years into the future, we'll have a civilization from Earth that inhabits Mars. And we will have youngsters, second-generation Martians, who will say, hey, my grandmother and grandfather back in the umpteenth century came from Earth. And it will be a relationship, Earth-Mars relationship, very much like an old country, new world relationship we have seen in the past 3 or 4 centuries.
If we do set up a human civilization on Mars, that will create the incentive for further advances in interplanetary transportation. Just as Columbus ventured the Atlantic in 3 ships that were really designed for the Mediterranean, and that no one in their right mind, even a century later, would have attempted an Atlantic crossing with. But once people found out there was something to go to across the Atlantic, once they made something worth going to across the Atlantic, that became an incentive for the advance of naval architecture. So we went from those carracks to clipper ships, to steamships, to Boeing 747s. Now the same will ultimately be true with Mars.
It has always been our nature to dream the impossible. Soon we can send the first human explorers to the surface of Mars, safely and economically, using technology that's almost ready today. Getting humans to the red planet could finally answer many of our long-held questions. Why did Mars become so cold and dry? How much water is left on the planet? Was there ever life on Mars? Is there any life there now? And there will surely be more surprises, discoveries we can't even imagine, just waiting at Destination Mars.
Don't go away. Discussion topics, activities, and resources are up next on Assignment Discovery. Now that you've seen Destination Mars, Part 2, talk about this. When scientists land on Mars, they plan to build a small greenhouse to test the soil for carbon dioxide. The results of the test will determine whether Mars could one day be terraformed. Debate the potential long-term environmental risks and ethics of using terraforming to change a planet's environment to make it more suitable for human use. Now try this. Design your own method for turning a hostile environment, such as an arid desert or the freezing Arctic, into a safe area to grow food and house people. What changes would you make to the landscape? What supplies would you need? Log on to DiscoverySchool.com for curriculum materials and resources to support Destination Mars. To learn more, Assignment Discovery suggests managing Mars.